In early March 2012, a powerful X-5.4 flare erupted on the Sun. The blast was observed by the fleet of spacecraft dedicated to monitoring our star, plus one unlikely addition, NASA's Fermi Gamma-ray Space Telescope. For Fermi, which detects high-energy gamma rays, the Sun is almost never the brightest, steady source in the sky. That distinction is reserved for the Vela pulsar. But on March 7th, the Sun outshone everything else Fermi could see. Thanks to the big flare, the Sun had become the brightest object in the gamma-ray sky. Due to the keen angular resolution of Fermi's Large Area Telescope, for the first time, scientists were able to narrow down the position of the high-energy gamma-ray emission to a part of the Sun's disk. This gives scientists greater confidence that the gamma rays come from the same region as the solar flare seen in other wavelengths. During this event, the LAT detected the highest energy light ever recorded from a solar flare. The gamma rays peaked at 4 billion electron volts, or 2 billion times the energy of visible light. With Fermi recording high-energy gamma-ray emission for 20 hours after the event, the March 7th flare also set a duration record. Several mechanisms are behind this gamma-ray activity. Flares are thought to arise when strong magnetic fields undergo a process called reconnection and release pent-up energy. A sudden blast accelerates charged particles, some of which leave the Sun, while others are driven toward its visible surface. Many of these accelerated particles are protons. When they collide with gas in the Sun's atmosphere or surface, the interaction creates a particle called a pion, which quickly decays into 2 gamma rays. These observations herald Fermi's arrival as a solar observatory, a powerful new tool for understanding the Sun as it approaches its maximum period of activity.